Okay, guys, I'm going through, I just want to go through some more examples of some simple probability problems, just to get you a little bit more familiar with things. Some of these are just going to be simple probabilities. Some of these are going to be, we're going to do some addition, and some of these we're going to do some multiplication examples. And I also have something, a little something to add into it as well when we talk about uh, mutually exclusive things and also inclusive things. We didn't really talk about inclusive the other day on the video, so I want to kind of go through and cover that, and you'll understand it once we start going through examples. Um, but I want to go through some of these practice examples, and you don't have these in notes, so you'll just have to write these down on some paper. Um, so that way you have examples, to kind of look at and get an idea. Or again, you can always go back and watch these videos and rewind and watch these again. But I want to go through some of these to help you out maybe a little bit, have a better understanding of probabilities. And when we get back from break, we're going to go through some more examples, but we're also going to get into a lot harder probabilities as well. Okay, first one, it says here, one of these cards will be drawn without looking. So you have, these are the cards that are here, okay? And for example, number 8, they did it for you already. They want to know what's the probability of you getting a 2. Well, in this case, there's 12 total cards here. And so 12 is our total, and the number of 2s that we have up here is 1. So the probability of you drawing a 2 is 1 out of the 12 cards possible. Okay, so they want to know what is the probability of you pulling a 5. Well, I look at my list. I know I have 12 cards total, and I see 1 5. So the probability of me rolling a 5, or in this case, drawing a 5, is one. There's 1 5 out of 12 total cards. So it'll be 1 out of 12. Okay, problem number 10. What is the probability of me drawing a J? Well, I look at my list of things, and I see 2 J's. There's 2 J's out of 12 cards. So if I reduce that, that'd be 1 out of 6. Okay. So again, I'm looking for the number of things that we have divided by the total number of things. I want to know in number 11, what's the probability of it being a number? Well, as I look at my cards, I see 1, 2, 3, 4, 5, 6, 7, 8 numbers. So the probability of me getting a number, drawing a number, is the 8 numbers that I have out of the 12 total, which again, if I reduce that, that gives me 2/3. Okay, probability of me drawing a 4. In this case, I believe there's 2 4s up there. So it'd be 2 4s out of 12 cards total, which would be, again, 1/6. Whoops. Probability of me drawing a T. Well, as I look at my cards, wait a second, I don't see any T's. So what's the probability of me drawing a T? Well, that's 0 out of 12. I don't have a chance to get a T. And then the last one, what's the probability of me drawing a letter? Well, right now I see 1, 2, 3. I see 4 letters. So it's 4 letters out of the 12 total cards, which happens to be 1 out of 3. Okay, again, these are simple probabilities in these examples here. Let's go down to the next few examples here, and now we're talking about cards. So it says here, one card is drawn from a well-shuffled deck of 52 cards. It says here, what's the probability of the drawing? So I want to know, what is the probability of you drawing an ace? Well, there are 4 aces in a deck of 52 cards. There's one of each suit. So there are 4 aces out of the 52 total, which I believe, if I reduce that, that's 1/13. Okay, what is the probability of you getting a face card? Okay, a face card. Kings, jacks, and queens. There's 3 face cards for each suit. There's 4 suits. There are 12 total face cards in a deck out of 52 cards total. And again, if I reduce that, I believe that's 3 out of 13. Okay. What's the probability of you getting a red 10? Okay, so let's talk about how many red 10s are there. Well, we know there's a 10 of hearts, and we know there's a 10 of diamonds, and we know there's a 10 of spades and a 10 of clubs. Okay, so the spades and clubs are black, so they're not red. So there's only 2 red 10s in the entire deck. So in this case, it would be 2 red 10s divided by the 52 total, which in this case, this would reduce down to 1 out of 26. All right, number 18. The probability that you are not a diamond. Okay, so now, what's the probability of you being a diamond? Well, how many diamonds are there in the deck? There's 13 total diamonds in the deck. There's 13 of each suit. Okay, so if I want to find this, in this case not a diamond, I'm going to take everything, or 52 out of 52, which is 1, minus the 13 that I know that are diamonds to get my answer. So 52 out of 52 minus 13 out of 52 should be 39 out of 52. Okay, 39 out of 52. So that's the probability of you not getting a diamond. Okay, so again, these are simple examples of simple probabilities. And so now we're going to go through some other examples that are going to make this a little bit more challenging. Okay, so if you remember, when we talk about complements and complementary events and all those types of things, for any event, the probability of an event happening plus the probability of an event not happening should be equal to 1. Okay? That is, in other words, the probability of an event not happening is really 1 minus the probability of it happening. Okay? So it says, suppose an event A has a probability of 3 over 8, 3/8. What is the probability of it not happening? So essentially, what I'm going to do is I'm going to take 1 and I'm going to minus 3/8 from it. Well, 8/8 minus 3/8 gives me 5/8 left over. Okay, so essentially, if the probability of it happening is 3 out of 8, the probability of it not happening is 5 out of 8. Essentially, what's left over? It says, suppose the probability of snow is 0.58. What's the probability that it will not snow? Well, I'm going to take 1 minus 0.58, and that's going to give me, in this case, 0.42. So the probability of it not snowing is 0.42. Okay, now we're going to look at, again, to kind of review mutually exclusive events. Okay, if A and B are mutually exclusive, that means they're totally separate from each other. One does not affect the other. Okay, they're not a part of two groups. They're mutually exclusive. They're totally separate. Now, the part that we hadn't talked about the other day, but we're going to talk about today, are inclusive events. And you see, it says here, the probability of A or B, remember the word or means we're going to add our probabilities. These are two essentially disjoint events, okay? Except the problem here is when we add these, there are some times where we can add these two probabilities and we'll end up with more than one, which is not possible because the problem is on inclusive events, the probability of A plus the probability of B, well, there are things that we end up what we call double counting for. Okay, for example, I'll use, let's see here. I'll use an example of the probability of it being a face card or a king. Well, there are kings that are face cards. So you're double counting. You can't double count for something. For example, if I were to use like a spinner or rolling a dice, okay, if I ask you for the probability of it being an even number or a 2, well, now you're adding the probability of an even number, which is 2, 4, and 6, with the probability of it being a 2. Well, see how you're double counting 2? Okay, so in this case, the inclusive events, we have to figure out, okay, and what I'm going to do is I'm going to draw a Venn diagram and draw a picture for you so you can see it. The easiest way to do these is to draw pictures so that you can see what it is you're looking for and see, okay, is there anything in here that's going to overlap, I guess is what I should say. Okay, so I want to know in example number 3, it says here, a card is chosen from a well-shuffled deck of 52 cards. What is the probability that card can be a king or a queen? Okay, so what I'm going to do is I'm always going to draw two circles. Sometimes these circles will overlap, sometimes these won't. Can I be a king and a queen at the same time? No. So in this case, these are my kings, these are my queens. Okay, how many kings are there? Well, there are 4 kings. There's one of each suit. And how many queens are there? Well, there's 4 queens. There's one of each suit. Okay, and if I wanted to, I could draw the suits in there. I'm not going to waste the time on that. Okay, so what is the probability of you pulling a king? Well, that is 4 out of 52. What's the probability of you pulling out a queen? That is also 4 out of 52. And what I'm going to do here now is add these guys. Well, when I add these guys, I end up with 8 out of 52. So the probability of you being a king or a queen is 8 out of 52. And yes, you probably want to reduce that. So we would reduce that by 4, which this would be 2/13. Okay, 2/13. Okay, the probability of you being a red jack or a black king. Okay, so can you be a red jack and a black king at the same time? No, because one's red, one's black. They're totally separate things here. So I'm going to draw 2 circles again. Oh. 2 circles, like so. This is my red jacks. And this is my black queens, or kings, I mean. Okay. And so now, how many red jacks are there? Well, there's a jack of hearts, and there's a jack of diamonds. How many black kings are there? Well, there's a king of spades, and there's a king of clubs. So in this case, what I'm doing here is the probability of you being a red jack is 2 out of 52. Plus, the probability of you being a black king is also 2 out of 52. And that's going to end up being 4 out of 52, which, if I reduce that, that should be 1 out of 13. Okay, let's take a look at the next example here. And let's see here. Problem number 6. We have an even card or a red card. Okay, now, quick question. Can you be an even card and can you be an even red card, in other words? Can you be an even card and a red card at the same time? The answer there is yes. These are not mutually exclusive. So when they're not mutually exclusive, I'm counting for things twice. So what's going to happen here is on my circles that I'm going to have, my circles are going to intertwine. So my one circle is going to intertwine with the other circle like so. Okay, and so now what happens here is I want to know these guys are the even cards and these guys are the red cards. Okay, so how many total red cards are there? Well, there's 26 red cards. Half the cards are red, half the cards are black. Okay, but of those red cards, how many of those red cards are even? Okay, so sometimes, a lot of times, what you want to do on these is write this stuff out. So here are your list of cards. You have 2, 3, 4, 5, 6, 7, 8, 9, and 10, right? And then you obviously have your king, queen, jack, and then you have your ace, okay, for your, and then you have a jack, a queen, and a king. There's your 13 cards. Okay, so as you look at the deck, how many even cards are going to be in the deck? Well, as I count these, there's 1, 2, 3, 4, 5 even cards in each suit. Okay, there's 5 even cards in each suit, which means there's 4 suits, though there are 20 total even cards. Okay, 20 total. So there are going to be 20 total even cards. There's 20 total evens, and there's 26 total reds. Okay, but I'm not going to separate these because some of these evens are red as well. Okay, so let's talk about the even cards. I know for sure that I have 5, in the black cards, I have 5 clubs. And I'll try and, it's not a very good picture because it's so small. And then I also have 5 spades. Like so. Okay. Because I have 2, 4, 6, 8, 10 of clubs, 2, 4, 6, 8, 10 of spades. And then I also now have 2, 4, 6, 8, and 10 of hearts. So I have 5 hearts. Maybe it'd be easier if I did this. All right, so I have 5. I have 5 hearts. Those are red. And then I also have 5 diamonds as well. Now notice, as you look at this, in this left circle right here, 5, 10, 15, 20. I said there's 20 even cards. Okay? There are 26 red cards. Well, 10 of the 26 red cards are even cards. The other cards, there's 26 others of them. So there are, and I'm not going to write these all out, but there are 16 total other red cards. Okay, so I want to know, what is the probability of me getting an even card or a red card? And you'll notice from the picture that there's 20 even cards plus 26 red cards. But if I just do 20 plus 26, these 10 cards right here get counted for twice. And I can't do that. Okay? So there are 10 cards in that middle spot right there that I can't double count for. So here's how I'm going to do this. Okay, how many even cards are there? Well, there are 20 out of 52 cards. Plus, how many red cards are there? There are 26 out of 52 cards. Now, how many of these cards were counted for twice? Well, the 5 hearts and 5 diamonds were counted for twice, so I have to take out 10 that were counted for twice. So 20 plus 26 is 46. Minus 10 is 36 out of 52. So I have the probability of me pulling out an even card or a red card is 36 out of 52. Okay? So that gives you an idea of one that's an inclusive one. In other words, things are included in both groups. That's why we call it inclusive. Okay, now one last part that I want to go through, and this is we didn't do any and examples. So it says here a spinner number 1 through 10 is spun. Okay, each number is equally likely to be spun. What's the probability of, and I put these numbers up here, so again, sometimes it's easier to list this stuff out. So you see it, how many of these, because they're going to ask all different kinds of things. So I want to know, in 2 spins, what's the probability of you getting an odd number and a 6? Okay, an odd number and a 6. And you'll see the key word here, the word and. Remember, the word and means to multiply. Okay, so what is the probability of you getting an odd number? Well, there are 1, 2, 3, 4, 5 odd numbers out of the 10 numbers total. So we've got 5 odds out of the 10 total, times, how many 6s are there? Well, there's 1 6. So I end up with 5 out of 10 times 1 out of 10, which ends up being 5 out of 100. Well, 5 out of 100 is 0.05. And I want you to think about this for a second. 0.05. Well, that's a 5% chance. You have a 5% chance of spinning an odd number and a 6. Is that very good? No. Think about this. On a spinner, how hard would it be to flip an odd number and then a 6? That's actually pretty hard. So that makes sense. This should not be a very big number. Okay? So, what's the probability of you spinning a number less than 8 and a 10. Well, a number less than 8, there are 7 numbers that are less than 8 out of the 10 numbers total, times, probably spinning a 10 is 1 out of 10. Well, that's 7 out of 10, which is 0.07. So that's saying you have a 7% chance to spin a number less than 8 and then a 10. Okay, so this gives you an example of a couple of and problems in there as well. All right, now this should help, hopefully. And so now you should be able to complete practice B and along with practice A, and make sure we have these guys ready to go. I may change the date on both these assignments for you. I'll probably change them to the Tuesday when we come back. So and then we're going to talk about these and work on these some more when we come back.